take a look at this problem that we have. So again, continue with 8.4. Let's say that we have this particular problem. And one thing is, like I mentioned, is if they don't give you a mean, if they don't give you a standard deviation, and the only thing they give you is the number of sample and the number that fit the category that we want, then this, most of the time, if you climb through this thing here, this will be your proportion problem. And that's the difference between proportion versus the mean, because the mean problem, they will give you the mean and they will give you the standard deviation. Okay, but again, looking at this thing here, they say that a marketing manager for a cell phone company claimed that more than 55% of children in the age of 8 to 12 have cell phone. So in a survey, he conducted a survey, 802 children in the age of 8 to 12 by the National Consumer League. 449 of them have cell phone. Can you conclude the management claim is true? So again, this is what we have, which is he want to know is 55% of the children in this age group have cell phone. So if you look at this thing here, we can see clearly this is our level of significance, which is our alpha, right? And as always, all of this thing here, we want to know what is given to us and what do we need to test, right? So if you look at this thing here, hopefully you guys see that the N, which is the total sample, the total children that we survey, is 802. And out of that 802, 449 of them have cell phone, right? And again, the alpha is there, is easy to recognize. The only thing left is we need this specific number, or we need this goal or this number that we want to test against, right? So looking at this thing here, hopefully you guys see that that number is the 55% or the proportion of the population, right? This thing here is, again, he want to claim that more than 55% of the children, which is the 55% of the population that he want to test, have cell phone. So that's why this thing here, the P sub 0, which is the testing point, right? The point that we use to test, or the population proportion that we have, is 55%, which is 0.55. And again, once we have this three items, the N, the X, and the P sub 0, now we can do the testing, which is looking at this thing here. Before we can do any testing, we have to ask ourselves, what is our H sub 0, the null hypothesis, and what is the H sub 1, the alternative hypothesis, right? So if you saw this number of P sub 0 equal 0.55, then again, the null hypothesis will be P is equal to 55. The population proportion is equal to 55. And again, what does he want to test? He wants to test that the proportion is bigger than 0.55, which is P is greater than 0.55. And if it's greater than, we know that this thing will tell me that this is a right tail test, right? The outcome, or not the outcome, but the criteria is the same, because again, right tail tests tell us that we're looking for something greater than this given point. And once we have this, we have to use, or we're using our calculator, which is we're using the one prop Z test. And again, when you use the one prop Z test, you need this three item, which is the N, the P sub 0, and the X, which is they give that to us. They give us the N, they give us the P sub 0, and they give us the X. And like I mentioned, this problem compared to the previous Facebook problem, the Facebook problem doesn't give you the X. You have to manipulate your equation to find that X value. But this one here, they give you the X. So if you type it in, you can see that the Z is equal to 0.56 and the P value is 0.2875 or 749. So looking at this thing here, you can use the P value. Reminder, there are two methods, which is the P value. All you do is you say, well, the P value is bigger than my alpha, bigger than my level of significance, bigger than the cutoff percentage that I say. If the P value is bigger than the alpha, we do not reject. That's one way, which is the p-value. You take the p-value and compare to your alpha. If you don't, then you have to use this critical value, which is the critical value for the proportion, z proportion. We use the z critical value. And reminder, the z critical value is basically you go to your z table, which is again, you go to your z table, or not z table, you go to this table, the T 8.3 table, which is again, reminder that this table, we have the alpha on top, which is whatever this decimal up here, this is your alpha that you have. And if we're using the T critical value, the T critical value is here, which is we need the degree of freedom. And again, if we're using the Z is down here. This is my Z critical value that I have. And again, this is the same table that we use in chapter 7, which is the chapter 7, we use the confidence level. Chapter 8, we use the alpha. So for our critical value, our alpha is 0.01, which is 1, 2, 3, 4, 5. The sixth column, which is again, sixth column is 0.01. We go all the way down to the Z, which is the Z, 1, 2, 3, 4, 5, 6. The sixth column, which is again, my Z critical value is 2.326. So looking at this item here, my right tail test, my critical value is 2.326, which is, that is my boundary. And on the right of this thing, I know that that is my reject region. On the left is the fail to reject. And now what is my test statistic? My test statistic is my Z is 0.56. 0.56 is somewhere here, which is under the fail to reject. So the result, regardless of you using a critical value or you using the p-value, the result should be the same, which is do not reject the null hypothesis. Do not reject the H sub 0, which is fail to reject. And if you fail to reject, your conclusion is you don't have enough evidence. We don't have enough evidence to support, we don't have enough evidence to say that more than 55% of the children in the age group of 8 to 12 have cell phone. Okay, so again, you know, this is the idea behind this testing is this commonly one, you know, for instance, they say, oh, this marketing is good. Let focus on this group of people. Let's design this cell phone that attract this group of people. So before they design a cell phone, they want to know if it's possible more than 55% of them buy the cell phone or have a cell phone, right? So again, they do the test and they say, oh, based on the information we have, no, we don't have enough evidence that is proof that more than 50% of them. So we say that because we don't have enough evidence, we might not want to create this cell phone, right? If you go in and you invent the cell phone and then all of a sudden not many people buying it, you will lose profit, right? So that's what statisticians do, right? They do all this number, they took all the number, they put in a test, and then they make a decision. So this thing here, we have a conclusion that we don't have enough evidence. For now, let's put this invention a bit further. Let's do more research. Let's have more data. And when we see that there is enough evidence, then let's go ahead and create this cell phone so that we can sell out, right? So again, that's the idea of the hypothesis testing. But to go back to this thing here, just reminder again, first of all, question on where my number come from, or question on how to use your calculator, or any question at all with this item that I have on the screen right here. So again, this is all there is in 8.4, ladies and gentlemen, which is we're using the one prop Z test. And again, one prop Z test is the same, which is you go stat, you go to test, and you go down to option 5. I can show you that in a little bit later. But again, if you don't have question with this problem, let's take a look at, let's review chapter 8. And like I mentioned earlier, my purpose for today is hopefully by the end of the meeting, you guys have a clear information in terms of how do or what do you look for when you use the z-test, or when do you use the t-test, and when you use the one proportional z-test. Those are the only three tests, which is the three items that you use, not the three items, but it's the same criteria that you use in chapter 7. So if you know how to do chapter 7, chapter 8 is identical. So let's take a look at this problem, right? If you glance through, you see that part A, they ask you to state the hypothesis. Part B, verify if we're using the z-test or the t-test. And then again, calculate the test statistic, find the p-value, and do we reject the h sub 0, and state your conclusion, right? So again, instead of telling you to do the 5-step, they ask you the 5-part. So let's take a look at the problem, right? The problem, the Russell 2000 is a group of 2,000 small company stock. On June 21st, 2013, a random sample of 35 of this stock has a mean price of $26.89 with the standard deviation of $23.41. The stock market analysts predict that the mean price of all 2,000 stock would be $25. Can you conclude the mean price is different from the $25, right? So looking at this thing here, we know that we need to test the difference. And again, the difference, which is not equal to. It's not less than, it's not greater than. The difference is basically is not equal to. So hopefully you guys say that, okay, they give us the mean and they tell you this. And hopefully, if you remember, I told you that if they write it this way, with the standard deviation, what does it mean? With the standard deviation, meaning out of this 35 sample, we got this mean, which is this is the sigma mean with the sample standard deviation. And that's the key word is, again, like I mentioned in chapter 7 and chapter 8, the same. If they don't spell it out for you, if they don't say with the population standard deviation, or if they don't give you that sigma, that small canon symbol, which is the population standard deviation, then we are deal with a sample standard deviation. And if we deal with a sample standard deviation, hopefully you guys will see that we are dealing with a t-test or t-interval in chapter 7. So before we do that, again, looking at this thing here, what information do they give us, right? We want to have this habit of list the given item. So clearly, hopefully you guys see that 35 is your n, which is the random sample that we have, 35. And again, with that sample of 35, we come up with this mean, which is, again, the x bar, which is the sample mean, is 26.89. And of that, we have a s, which is a sample standard deviation, right? And again, the 25 is your specific value. Some student might ask, how do we identify what is this mu sub 0 is? 90% of time, right? 90% of time, the value in your question, the question they ask you is this. They ask you, can you conclude the mean price is different from whatever this specific value is? So 90% of the time, the mu sub 0 is in the question itself. As you will see, whatever this number is, that is the specific value, or that's the goal that we try to test, right? You ask yourself, what are you trying to test? You try to test the difference from the number 25, which is, again, your number 25 is basically your goal, right? Your goal that you want to test, right? So looking at this thing here, hopefully you see that once we identify the mu sub 0, the hypothesis of this, which is the mu, the null hypothesis will be mu is equal to 25. And the alternate, because they ask us to find the difference, which is the difference basically tell us that it's not equal to. Why is important? Because not equal to tell us that this is a two-tailed test. So because it's a two-tailed test, we know that we have two on the left side, two-tailed, which is one on the left side, one on the right side, right? Which is, we know that this is my reject region, the left and for right, and the fail to reject region is there, okay? In order for me to know if reject or not, we have to do all the rest of the testing, Okay, but before we do that, so again, this is what the point of the two-tail tell us, give us the idea that this is our region, which is again, critical region is here, the reject is the critical region, the fail to reject is just the fail to reject region, right? So go to B, so we answer A, which is again, they just ask us to state, we have to know why we state and form the hypothesis, what kind of test we have, which is what kind of tail we have, okay? So B, should we use the Z or the T? And again, we use in the T test just because they give us, the problem give us the sample standard deviation or the lack of population, population standard deviation, right? If they spell out population standard deviation or if they give you that symbol, then the symbol of sigma, then we use the Z, okay? So because we deal with a sample standard deviation, we use in the t-test. So if you do the t-test and they ask you to calculate the test statistic. So if you calculate the test statistic, ladies and gentlemen, which is again, we go to, let's see. This is what we ask you, or this is what I ask you guys, or I'll have you guys to do, which is again, all we're doing is we go to stat, right? We go to stat and we go over to test. And then we go to the t-test, which is number 2. Reminder, again, your z-test is number 1, your t-test is number 2, and your one prop z-test is number 5, okay? So again, if you use the t-test, which is make sure that you type in the data, which is the data is what we have. And again, my mu, which is 25, okay? So I have the information prior, which is again, 26.89. 2341, my N is 35, and make sure you choose the two-tail test, not the left tail, not the right tail, the two-tail, and then you choose your calculate. So if you calculate this thing here, which is, this is your T is 0.4776, and your p-value is 0.6359. Okay, so did everybody have this number here, which is the T is 0.4776, which is 0.478, and the p-value is 0.635. Again, make sure that you know how to utilize your calculator. Make sure that you know how to input in your data. So question with part C, which is again, they ask you for the test statistic. The test statistic is the T test statistic that we have, and the p-value, which is the p-value is here. I should say p-value instead just p, so that you won't confuse that the p is a proportional. But again, this is the p-value, which is I extract from the calculator. So if you do D, if they don't ask us for a critical value, which is fine. If they ask us using this alpha, do we reject? If you use the p-value, everybody see that the idea of the p-value is if the p-value is bigger than the alpha. In this case, 0.6 is way bigger than 0.05. If the p-value is bigger than the alpha, we do not reject the null hypothesis. Okay, so again, the p-value is basically this number here is bigger than alpha, we do not. If the p-value is smaller than the alpha, then we reject the null hypothesis. So in this case, you can see that compared to p-value, we do not reject, right? But let's take a look at how do we find a critical value if they were to ask you to find a critical value. So to find a critical value, because we deal with a t-test, because we deal with a t distribution, to find a critical value, we need the degree of freedom. And reminder, the degree of freedom is n minus 1, which is in this case, the n is 35 minus 1 is 34. And the other thing is, in order for us to find a critical value, we need alpha. But ladies and gentlemen, make sure that you remember that this alpha is just an alpha, but because we have a two-tail test, because we have a 2 endpoint here, we need to take this alpha and divide by 2, and we're using this number here, 0.025, not 0.05. If it's a left tail, we use 0.05. If it's a right tail, we use 0.05. It's because it's a two tail, we have to divide this alpha by 2, which is 0.025. Okay, so looking at this thing here, if you go and reminder, if you go to this table, reminder again, because of our item, when we divide the alpha by 2, this is what I have, which is 0.025. That is my alpha, that is my level of alpha. And then all I need to do is take that level of alpha and go down to 34. So again, my degree of freedom is 34, which is everybody see that my degree of freedom is 34 here. And my alpha, which is on top, is 0.025, which is, this is what I have, which is my critical value is 2.032. Okay, so again, if we deal with a T, all of this item in here is the T critical value. It's depend on your degree of freedom, which is, again, this is what we have here in terms of your T critical value. If you're looking for the Z is on the bottom here. This is the Z. Okay, so looking at this thing here, we know that our critical value is 2.032, which is, again, looking at this thing here, we know that this is what we have on the left side is negative 2.032, and on the right side is positive 2.032. So now, if you don't use the p-value, you use the critical value, which is now, do you agree that this T, 0.47, is somewhere in the middle here? This is where my T, which is 0.478, which is because it's in this fail to reject region, we say we do not reject the H sub 0. And if you do not reject H sub 0, your conclusion will be you don't have enough evidence, right? We do not have enough evidence to support that the mean price is different from 25, okay? We not say that it's equal to 25, we just say that for now, we don't have enough information that the price is not equal to 25, okay? We have to do more study, right? So again, maybe the stock in there, there's some small, some large, but again, we don't know. We just don't have enough evidence right now. Okay, so again, this is the idea of your test, and this is what you guys need to do in the sense of your hypothesis test. And when we relate to anything with the mean, again, this is what you ask yourself is, can you conclude that the mean price or the mean, whenever you conclude the mean, you either do the T or a Z test. In this case, the T test, because we deal with a sample standard deviation. Question with this particular problem, any particular question on how I got the number on the screen, or any question on anything with this problem here? All right, if you don't have question, let's take a look at this problem here, which is, again, if you glance through this, which is, again, you know, can you conclude, right? Can you conclude that the mean, so again, we either deal with a T or a Z test, which is, that's what they have. Can you conclude the mean number of TV set per household is greater than 3? So again, what does this greater than 3? Remember, I told you guys that this number in your question, this is the specific number that we want to test, right? This is the goal that we want to test, which is we want to see if it's greater than, bigger than 3. Right? So again, looking at this thing here, and again, if you glance through and you saw this thing here, and hopefully you say, hey, Mr. Tran, they give us this item here, which is very nice of them. They spell it out for you, right? They spell it out, which is population standard deviation, and make sure that you guys know that if we deal with a population standard deviation, then we are dealing with this test right here, which is the Z test. So on the prior problem, I told you that if they don't give you the population standard deviation, or if they don't give you this symbol, this sigma here, if they don't give you this two, population or the sigma symbol, then most of the time, the way that they stated, they say with the standard deviation, meaning most of the time it will be the sample standard deviation. Now, in this problem, they spell it out, right? They say population standard deviation, that should be a hint, that should be a Z test, or in chapter 7, Z interval, okay? So looking at this thing here, let's see what they give us, right? A survey organized sample 60 household. So that 60 should give you an idea that that 60 is your N, right? 60 household in the community, and found that the sample mean Sample mean, that's your X bar. Sample mean TV set per household is 3.1. So again, out of that 60 household, the average TV set is 3.1. It's not that 3.1 of the TV is, is close to 3, right? Close to 3 TV set, right? So again, the population standard deviation, which is spelled out for you, the population standard deviation, which is your sigma, right? And again, the last item is your 3, which is, again, hopefully you guys see that the 3 is that specific value, that item that we want to test, right? We want to test against or more than 3. So what does it mean more than 3? Well, more than 3 tell us that the hypothesis is either equal to 3 in your null hypothesis or greater than, which is mu is greater than 3, right? So again, either you have the mu is equal to 3 in your null hypothesis, or the alternate hypothesis is mu is greater than 3. And again, greater than 3 tell us a few things, which is tell us that this is a right tail test. And if it's a right tail test, this will be my sketch, right? My critical value, the reject region will be on the right because it's a right tail test. And my fail to reject region will be the item on the left, right? So again, all this preliminary is all the same, right? You sketch it so that you know your critical region. So now, go with B. B, they ask you which test, which is we answer this when we look at the problem already, which is we know that this is a Z-test. Why is a Z-test? Because they give us the population standard deviation, right? So this is what we have is a Z-test statistic. And again, they give us the population standard deviation. That's why we use the Z-test. And now for C, they ask us to compute the value for the test statistic and the p-value. So looking at this thing here, the only thing different between this problem versus the prior problem is we do stat, we do test, but instead of the t-test, we use in the z-test. And again, all you do is you go into your stat and you just type in your data, right? You go stat, you go to the test, and then we choose in the z-test, which is again, my data is again, my mu is 3, right? And then my standard deviation is 1.5. My sample mean is 3.1. And my n is 60. And again, this is the most important thing also is, ladies and gentlemen, make sure that this is the left tail right here. The blinking item is the left tail and the right tail is this item. Make sure you choose the right tail. So whatever your symbol right here, mu is greater than 3, whatever this symbol, that is the symbol you want. Don't worry about your mu sub 0. That mu sub 0 is basically tell you that the specific number. So again, whatever the inequality you have in your alternative, that is the inequality that you want to choose. So again, make sure that you have this item here because your test statistic won't be wrong, but your p-value will. Okay, but again, if you do this thing here, which is this is your Z test statistic, which is 0.516, and your p-value, which is 0.3027 or 28, right? So again, this is where we have, which is looking at this thing here. This is the two items they asked me, which is the Z test statistic, which is Z equal to 0.516, and the p-value is 0.3028. So I'm done with part C. Now part D. Can we reject H sub 0? Again, without doing the critical value, everybody see that the p-value is bigger than the alpha. And if the p-value is bigger than the alpha, we still do not reject. Again, the p-value bigger than alpha, we do not reject the H sub 0. And if we do not reject, the conclusion will be we don't have enough evidence, right? So again, looking at this thing here, how do we find the critical value? The critical value reminder, because we deal with a z-test, we have to find, or we have to do with a z confident or the z critical value, which is our alpha is this, ladies and gentlemen, our alpha is 0.01 because it's a right tail. So the alpha, we use in the same alpha, we don't divide anything. We only divide if it's a two-tail test, okay? Even with the z-test, or a t-test, or the proportion. If it's not equal to, then when you're looking for your critical value, you have to divide by 2 because it's a two-tail test. But again, if you go down all the way to the bottom, which is, again, this is my, that's the further I can go. My Z is 2.326, which is, again, that's my Z, which is 2.326. That is my critical value right here. So again, once I have that critical value, all I need to do is go here and say, well, that is my critical value. That is my boundary, right? We already make the decision that we do not reject, which is, again, the Z is just to verify that the Z is somewhere here. And if it's here, it's under the fail to reject, which is the result is the same. Okay, so the result for the critical value method or the result for the p-value method, it should be the same, which is you do not reject your null hypothesis. And if you don't reject your null hypothesis, then you do not have enough evidence to support that the mean number of TV set per household is greater than 3. Okay, meaning, again, is either 3 or below. Okay, so again, looking at this thing here, if Best Buy want to get more TV, they say, oh, not many people are gonna buy it, right? So we should not get more in our inventory. Okay, but again, that's the idea of this thing here, that we don't have enough evidence. Okay, so again, first of all, question would, how to determine the Z-test versus the T-test? And if you can determine that, ladies and gentlemen, you know, this test 4, should be very doable. Just make sure that when you type in your test, make sure that you choose the right tail, the right symbol, I should say, not right tail. It can be right tail, could be left tail, right? So you choose the right symbol for your test in your calculator. It's either two tail, left tail, or right tail. In this case, right tail. Okay, the right symbol. So question with this problem on the screen. All right, if you don't have question, let's take a look at this item. So if you remember, I mentioned right in the beginning of class, if you glance through this problem, right? If you glance through this problem, few things to notice is they ask you, can you conclude that is less than 15%? So again, looking at this thing here, they don't ask you conclude the mean, right? They ask you, can you conclude that it's less than 15%, which is this 15% will be that specific number, will be that number that we try to test, right? But if you glance through this item without reading the whole story behind this thing here, if you just glance through, you can see that they don't give us the standard deviation, then they don't give us the mean, right? They don't give us anything in terms of sigma or in terms of X bar, right? So looking at this thing here, you should have an idea that, oh, we are dealing with a proportional item or a proportion item, right? So again, looking at this thing here, and like I mentioned to you guys, if you in doubt, right? If you in doubt and you see the problem with too many words, if you in doubt, just go in and just zoom out the number, right? If you go into this problem, which is, again, if you block all the word out, this is the only 3 number that you see, right? You see that the total, which is, again, the total should give you an idea that that is your N, right? And off that total, the 134, that should give you an idea that that is your X, right? So again, without reading the problem, everybody see that we can see that the number that we have is, again, I forgot to box this number, but this is the obvious number we have, right? But again, this is the only number in your problem. And again, we know that this is the total, which is the N. And again, off this total, 134, which is, that is your X. And what is the alpha, which is alpha is easy, which is that. And again, this thing here, which is, again, the P sub 0, which is the percentage or the proportion that we want to test, right? So again, you read this thing here, we know that we have some patient that insert this tube in the plus vessel, right? And then sometimes they have to come back within a year to have some treatment, right? So they ask you, can you conclude that less than 15% of the patient, which is this is our specific number that we want to test. Less than 15% of patients have to come back for additional treatment. So looking at this thing here, this is all we need for our proportion item, because again, we know that our mu will be P is equal to 15.15 or 15%. And again, because they ask us less than, everybody see that P is less than 0.15, right? Less than 0.15 meaning 0.15 is greater than P. And again, why do I emphasize this? Because this will be the left tail test, because it's point to the left or the inequality is less than. And if it's a left tail test, we know that this will be my sketch, right? Which is again, my critical value, not critical value, but critical region. The reject region is on the left and the fail to reject is on the right. And looking at this item here, can you compute the test statistic? So again, to compute this thing here, this is what you guys need to do, which is again, if you go into your calculator, you type in again, stat, go over to test, and like I mentioned, option number 5. And again, I mentioned this yesterday, which is you have a z-test, the t-test, and the one prop z-test. In addition to this, you have the z-interval, the t-interval, and the one prop z-interval for chapter 7. So those 6 features is under the same pattern, okay? So again, if you look at this item here, we have the one proportional t-test, or z-test, sorry. The p-hat, or the p sub 0 is 0.15 for us. And the x that we have, is 134. And the n that we have is 1,120. And make sure that you choose the right tail, the right symbol, which is in this case is the left tail test, not the right tail test, right? The left tail test, and then make sure you calculate, right? So again, if you don't choose the correct tail, your p-value will be wrong. Your test statistic will be the same, but your p-value will be wrong, and that will give you the wrong answer. But again, one thing I want to point out to you guys is hopefully you guys see that this is the z statistic that we have. That's your test statistic. The p without a hat, that is your p-value. The p with a hat, that is your sample proportion, which is to find the sample proportion, all they did was they took the x divided by the n. They took the 134 divided by the 1120, okay? So that's the p-hat. So if you extract your information, make sure you know what your output look like, which is the 2 number we're looking for is this 2 number, which is the z is equal to negative 2.845, and the p-value, I should write the p-value, is 0.0022. And because of that, we know that, again, given that our alpha is 0.05 and the p-value is 0.002, which is, everybody see that the p-value that I have right here is smaller than the alpha we have here. If the p-value is smaller than the alpha, then we say that we reject the 8 sub 0. We reject it. And if we reject it, we say we have enough information, okay? But again, let's go to the critical value. The critical value for 0.05, because we use a proportion z, we still using the z interval. And make sure that this is what we have, which is, again, the 4 column. 0.05 is right here, right? The alpha is 0.05, which is the 4 column. I go all the way down to the bottom to my z. The 4 column, 1, 2, 3, 4. The 4 column I have is 1.645, which is, if you remember, this is your common critical value earlier. But again, 1.645, which is, because it's the left tail, my critical value is going to be negative. Okay, if it's a right tail, it's going to be positive. If it's a left tail, it's negative 1.645, which is where is my negative 2.8. My negative 2.8 is somewhere to the left of this, which is under the reject region, which is regardless of which method you use. You either use a critical value You either use a critical value method, which is critical value method tell you that you have a critical item in your critical region, which is we reject. Or you use the p-value method, which is the p-value method. If the p-value is smaller than the alpha, we reject. If the p-value is bigger than the alpha, greater than alpha, we do not reject. So again, if we reject the H sub 0, we will say that we have enough evidence. We have enough evidence that less than 15% of the patient come back for additional treatment. Okay. So again, the other thing I want to point out is on your homework, I think they ask you for significant, statistically significant, to verify if they are statistically significant. I mentioned yesterday is if the p-value is smaller than the alpha, and if it's very small compared to the units, right? If this p-value is 0.049, if it's 0.049, which is very close to 0.05, then we don't say that it's statistically significant, right? It's only when the p-value compared to like this thing here is 5%. If you move the decimal, it's 5%. If you move the decimal, this thing is not even 1%, right? This thing is 0.22 of a percent. So compared to that, this thing here is very small to the 5%, which is we can say that this is statistically significant, meaning we are very confident that our conclusion is correct. Meaning again, the probability of type, the p-value right here is the probability of type 1 error, right? Which is this thing here. Is very small. Type 1 error won't occur, meaning the null hypothesis will not be true when we reject it, right? So again, type 1 is the null hypothesis is true, but we reject it, right? So again, in this case, we reject it, and we know that it's very small for this to be true. So that's why we are statistically significant, meaning we are, based on the statistic, we're confident that this will work out. Okay. So again, question with this item here, question with all the number I have on the screen or any of this thing here. So again, hopefully you guys see the difference between the t-test, the difference between the z-test, and the difference between a proportional problem, right? So let me ask you guys to try this one for me. I will give you 5 minutes to see if you can do, let's say if you have this problem on your test this weekend or on your test, on your quiz, see if you can answer this 5 part here. And I will give you 5 minutes to do it, and then we go over this.